Welcome to qnawire.
In question 101, you have a voltaic cell that's made from nickel 2 plus going to nickel solid as one of the half cells, and silver ion going to silver solid is the other half cell. They give the initial concentration of nickel 2 plus, and they give you the initial concentration of nickel 2 plus, and that's initial, and that is 0.0100 molar. And they give you the initial voltage. And the initial voltage they give you is equal to 1.12 volts. All right, and so part A asks us, in part A, they ask, by using the data in Appendix E, calculate the standard EMF of this voltaic cell. So the first thing we need to do is figure out what the reaction is here. So we have nickel ions, and they're going to, so we have nickel 2 plus going to nickel metal, and we have silver plus going to silver metal. And this is a voltaic cell, and since it's a voltaic cell, we know that the E cell must be positive because by definition, a voltaic cell is spontaneous. So if we look up the E's for each one of these, we get that the E for this is negative 0.28 volts, and the potential for this one is equal to positive 0.80 volts. So in order for this to be spontaneous, we're going to need to get a positive E cell. And for a positive E cell, remember E cell is equal to E reduction minus the E of oxidation. And in order for that to be positive, we would need to do the 0.80 volts minus the negative 0.28 volts, which would give us the answer for part A, which is 1.08 volts. That also tells us, that helps us with question B, because in question part B, they are asking us, will the concentration of nickel 2 plus increase or decrease as the cell operates? So from this information, we should be able to figure out what the overall reaction is. So this is the reduction reaction. Okay, so this nickel is being, or nope, here, silver is being reduced, nickel is being oxidized in this reaction. So that means that the nickel is starting out as nickel metal and it's going to nickel 2 plus. The silver is starting out as silver ions and it's going to the silver metal. And here's my balance. So I can see that as the reaction proceeds in a forward direction, I am forming more nickel 2 plus. Therefore, the concentration of the nickel 2 plus ions should increase as the reaction progresses. Part C, they ask us, what is the initial concentration of Ag plus in the half cell? So to do this, I'm going to be using the Nernst equation, where I know that E is equal to E naught minus 0.0592 volts over N times the log of Q. And it's the log of Q that I'm going to want to be finding, because I know that the log of Q is going to be equal to the concentration of my product ions. Not, remember, solids don't go in there, so this would be nickel 2 plus over the concentration of my reactants, so Ag plus. And I'm trying to solve for this. So I know they gave me the initial voltage, so that would be right here what the voltage was, because that's what I'm looking for, the initial concentration, so I want to use the initial voltage here. So this is 1.12 volts, and that was equal to E naught, which I calculated as 1.08 volts, minus the 0.0592 volts over, and the number of electrons being transferred is 2, because I have my bounce reaction, right? I have Ni going to Ni2 plus, it's losing 2, and 2 silvers are gaining 1 each. So I have 2 electrons here that I am that are being transferred, and that's going to be equal to the log of Q. So I can solve that, and I get that the log of Q is equal to negative 1.351. Therefore, I can raise both sides to the 10 to the both sides. Sorry, this is a log base 10 to the both sides, and I get Q is equal to 0.04457. And now I'm going to set that, I'm going to go back up here where I have Q, and I'm going to solve that first algebraically for silver. And what I did forget here is I forgot to square that, because it is 2 silvers in my equation here. So that would be Ag squared. So if I multiply Ag squared over to this side and divide by Q, I'm going to get that the concentration of Ag squared is equal to the concentration of nickel 2 plus over Q. And then I'm going to take the square root of both sides. So I know, I'm going to come down here, so I know that my concentration of silver ion is equal to the square root of the concentration of the nickel 2 plus over Q, which is equal to, and they gave me the initial concentration of the nickel 2 plus, that was 0.0100 over Q, which I calculated as 0.004, or sorry, 0, that's not a 0 here, that's 0.4457, and I get that the concentration of Ag plus is equal to 0.474 molar.